Moving on to the advanced problem. A researcher believes that treating seeds with certain additives before planting can enhance the growth of plants. An experiment to investigate this is conducted in a greenhouse. From a large number of Roma tomato seeds, 24 seeds are randomly chosen and 2 are assigned to each of 12 containers. One of the 2 seeds is randomly selected and treated with the additive. The other seed serves as a control. Both seeds are then planted in the same container. The growth in centimeters of each of the 24 plants is measured after 30 days. These data were used to generate the partial computer output shown below. Graphical displays indicate that the assumption of normality is not unreasonable. Determine if there is a significant difference in growth between the tomatoes with additives and the tomatoes without. Do not fear the phantoms. Alright, we shall start with the P in phantoms, parameter of interest. So the P this time is the mean difference growth between the tomatoes with additives and tomatoes without additives. Next, H. The null hypothesis, or HO, is that the mean difference, that's why the D is there, is 0, which means that the additives cause no change. The HA, or the alternate hypothesis, is that the mean difference is greater than 0, which means that the additives caused the growth. Next, A, assumption. The problem states that the seeds were randomly chosen and the additives were randomly assigned. And also the problem states that the assumption of normality is not unreasonable. So we're good to go. N, which test are we going to use? Well, we're going to use the matched pairs t-test. Well, the biggest hint is that they give us a difference, so you might as well use it, right? And also it's because we are applying 2 treatments to 1 sample. Like, we have 1 tomato and we're looking for the growth, and the 2 treatments would be the control and like with the additives and without the additives. So using that, we can use the match pairs t-test, and to test that we solve for the t, which is x bar minus mu over standard deviation over square root of n. This is also given to us right here. This value and this value goes right here and right here. Over square root of 12, there are 12 samples, and we get negative 6.002. And for all t-tests, you need a degree of freedom, which is n minus 1, sample size minus 1, which is 12 minus 1, 11. And so how do we find the p-value? So using this 6.002, we go to the back of the book, and we go to degree of freedom 11, and we look for the 6.2, but it's not there, which means that you go up top. This is the p value right here. Since it's greater than this, it is going to be less than 0.0005, the p value. And that's what we have here. The p value is less than 0.0005. So now moving on to the M, we reject the HO based on our p value, which is less than 0.0005. And which is less than our alpha value of 0.05 right here. We usually just use 0.05 because it's not rocket science nor candy. And so the final statement is, we reject the HO that there was no growth in tomatoes when additives were added, based on our p-value less than 0.0005 being less than our alpha value of 0.05. Therefore, there is a significant difference in the mean growth rate between tomatoes with additives and the tomatoes without.